We're going to do a lot with this derivative, but I want to just do a quick video just to talk about a key point that, again, is connecting what we just worked with the idea of the derivative being the same thing as the rate of change, specifically the derivative at a point, a value x equals a, whatever, is the same thing as the instantaneous rate of change. So we're looking at the derivative at that specific point. That's telling us how fast the car is moving at a particular time, or the rate of people entering or exiting a building at a particular time. We're looking at the rate that a function is changing at in a specific point. And we know that the instantaneous rate of change, that's the slope of the tangent line to the curve. All right, so we want to kind of put that as a key concept right here. Okay, we want to make sure that you know the derivative is the slope of the tangent to the curve at a point. Okay, that is a very key concept. There are times on the AP exam where they will ask you the question, what is the slope of the tangent to the curve? And then they give you the curve, they give you the function at the point x equals 2. All right, and if you've got this key concept down, you know that they're asking for the derivative, even though they didn't have the word derivative in there. All right, so the derivative is the slope of the tangent to the curve at a point. So we need a little song to remember this, okay? So work with the beat. The derivative is the slope of the tangent to the curve at a point along the way, hey. All right, way, hey. I think that fits on the screen there, all right? The derivative is the slope of the tangent to the curve at a point along the way, hey. Nice way to remember it, but you want to keep that in mind. The derivative is the slope of our tangent line to this curve at a particular point, okay? The derivative is the slope of the tangent to the curve at a point. Keep that in mind. That's going to help us as we work our way through this idea with the derivative. Now, we're going to get into more of those derivatives that have taken a little bit of time. We're going to take a quick time out from that and just start talking about the idea of when a function is differentiable and when it's not differentiable. So here's the key question to consider as we move to the next video, which is going to involve the graphing calculator. Why must a function be continuous at any particular point in order for the function to be differentiable at that point? Why do we need to have a continuous function in order for us to be able to take the derivative at that point? Okay, we've talked about continuity. We said that was a key concept leading into the derivative. So why do we have to have this continuous function, right? And I want you to think about that. I will talk about it more in the next video when we talk about spots where a function is not continuous.